Good morning, children. Today we move on to the fourth chapter, Quadratic Equations. In the first class, we have learned about the solving of a quadratic equation using factorization method. Now, let us move to the second method, which is method of completing squares. Here, we start with the standard quadratic equation, that is ax square plus bx plus c equal to 0 where a not equal to 0. The first step what we need to do is to make the coefficient of x square as 1. Here in the question it is ax square. To make it as 1, we need to divide throughout by a. So, we get it as x square plus b by a x plus c by a equal to 0. In second step, we need to shift the constant term to the right side. The constant term here is c by a. So, by taking c by a to the right side, we get x square plus b by a x equal to negative c by a. Now, in third step, we need to be very conscious how it comes. Just see what is the coefficient of x. Here we can see it is b by a. We need to take the half of coefficient of x. That means half of b by a, which is b by 2a. And now we need to square it. So it will become b by 2a whole square. Now we are going to add this b by 2a whole square on both sides of the equation. So our equation becomes x square plus b by a x plus b by 2a whole square is equal to negative c by a plus b by 2a whole square. The LHS is an expanded form of our first identity a plus b whole square, where in the place of a square we have x square and in the place of b square we have b by 2a whole square, which can be written as x plus b by 2a the whole square. Also on the right side we can see finding the square and finding LCM, it becomes b square minus 4ac by 4a square. In the next step, we need to take the square root of both sides. So we get x plus b by 2a is equal to plus or minus root of b square minus 4ac by 4a square. To obtain the value of x, we can shift b by 2a to the right side and we can find the value of x. We are going to show one example by using completing the square method. Question 1. 2x square minus 5x plus 3 equal to 0. As I already said, the coefficient of x square should be 1. We have to divide our equation by 2. So, the equation becomes x square minus 5 by 2x plus 3 by 2 equal to 0. The second step is to transpose the constant term. Here the constant term is 3 by 2. Taking that to the right side, it becomes x square minus 5 by 2x equals negative 3 by 2. For moving on to the third step, let us find what is the coefficient of x. Coefficient of x is 5 by 2. No need of taking the sign. Half of the coefficient of x, it will become 5 by 4. Squaring, it becomes 5 by 4 whole square. Adding 5 by 4 whole square On both sides of the equation, we get x square minus 5 by 2x plus 5 by 4 whole square equal to negative 3 by 2 plus 5 by 4 whole square. By adding square of half of coefficient of x, the left side always becomes the first or the second identity depending on the sign of the coefficient of x. In this question, coefficient of x is 5 by 2 and the sign is negative. So automatically we can take our second identity a minus b whole square, which will be x minus 5 by 4 whole square. The right side, as they are numbers, we can simplify it. Negative 3 by 2 plus 25 by 16, and finding LCM we obtain our answer as 1 by 16. So this 1 by 16 can also be written as 1 by 4 whole square. So our equation is rearranged as x minus 5 by 4 whole square equal to 1 by 4 whole square. Taking square root, it becomes x minus 5 by 4 equal to plus or minus 1 by 4. Here we can take plus or minus value as we need to get the two roots of the equation. Transposing 5 by 4 to the right side, it becomes x equal to 5 by 4 plus or minus 1 by 4. For a quadratic equation, we have two solutions. So in the first one we add and in the second one we subtract. Therefore x equal to 5 by 4 plus 1 by 4, which is equal to 6 by 4, and reducing it becomes 3 by 2. Or in the second is root we are subtracting, x equal to 5 by 4 minus 1 by 4, which is equal to 4 by 4, and finally equal to 1. Hence, roots of the equation are 3 by 2 and 1. Now, as we have learned how to solve a question with the help of completing the square method, let us move on to the exercise 4.3, page number 87. Question number 1. Find the roots of the quadratic equation if they exist by the method of completing square. When we move on to the question, 2x square minus 7x plus 3 is equal to 0, we can see the coefficient of x square is 2. We need the coefficient of x square as 1. So we are going to divide the equation throughout by 2. So our equation becomes x square minus 7 by 2x plus 3 by 2 equal to 0. Now in second step, we need to transpose the constant. Here the constant is 3 by 2. Taking the constant to the right hand side, our equation is x square minus 7 by 2x equals negative 3 by 2. Now in step number 3, the coefficient of x is 7 by 2 and we need to take half of coefficient of x, that is 7 by 2 divided by 2, which is 7 by 4. Square it. We can write it as 7 by 4 whole square, and this 7 by 4 whole square is added to both sides of our equation. Our equation is rearranged as x square minus 7 by 2x plus 7 by 4 whole square equals negative 3 by 2 plus 7 by 4 whole square. The left hand side is the expanded form of a minus b whole square. In the place of a square, we have x square, and for b square, we have 7 by 4 whole square. So we can write it as a minus b whole square which makes x minus 7 by 4 whole square on the left hand side. And the right side we can find the square, and simplifying we get our answer as 25 by 16, which is also a square number. So our equation now is in the form x minus 7 by 4 whole square is equal to 5 by 4 whole square. Taking square root on both sides, we can write x minus 7 by 4 is equal to plus or minus 5 by 4. Transposing 7 by 4, we can find the value of x. That means x is equal to 7 by 4 plus 5 by 4, which is equal to 12 by 4 equal to 3, or x is equal to 7 by 4 minus 5 by 4, which is equal to 2 by 4, and reducing it becomes 1 by 2. Therefore, the roots of the quadratic equation are 3 and 1 by 2. Question B. 2x square plus x minus 4 equal to 0. Dividing throughout by 2, equation becomes x square plus 1 by 2x minus 4 by 2 equal to 0. We are dividing by 2 to make the coefficient of x square as 1. Now transposing 4 by 2 to the right side, it is written as x square plus 1 by 2x equal to 2. We know the coefficient of x is 1 by 2. So half of 1 by 2 is 1 by 4. We need to square it and add it to both sides of the equation. So our equation is rearranged as x square plus 1 by 2x plus 1 by 4 whole square equal to 2 plus 1 by 4 whole square. Left side is the expanded form a square plus 2ab plus b square, and we can write as a plus b whole square. In the place of a, here we have x, and for b we have 1 by 4. So left side is written as x plus 1 by 4 whole square, and the right side 2 plus 1 by 16 is equal to 33 by 16. So the small rearranging is given. It is x plus 1 by 4 whole square equal to root 33 by 4 whole square. Taking square root, it is x plus 1 by 4 is equal to plus or minus root 33 by 4. For finding the value of x, we transpose 1 by 4 to the right side. Therefore, it is negative 1 by 4 plus root 33 by 4 and negative 1 by 4 minus root 33 by 4, which is equal to, the two solutions are negative 1 plus root 33 by 4 and negative 1 minus root 33 by 4. Question C, the students can practice. Now moving to question number D. 2x square plus x plus 4 equal to 0. Divide throughout by 2 to make the coefficient of x square as 1. So our equation is x square plus 1 by 2x plus 4 by 2 equal to 0. Now transposing 4 by 2 to the right side, it is x square plus 1 by 2x equal to negative 2. Coefficient of x 1 by 2. Half of 1 by 2 is 1 by 4. And the square of 1 by 4 is added on both sides of our equation. It becomes x square plus 1 by 2x plus 1 by 4 whole square equal to negative 2 plus 1 by 4 whole square. Left side is a square plus 2ab plus b square, which we can write as a plus b whole square, and the left side becomes x plus 1 by 4 whole square. And the right side is negative 2 plus 1 by 16, which is equal to negative 31 by 16. Actually, we need to write the right side also as a square term. Being negative, we cannot write it as a square term. So here we cannot find the roots as the right side is negative. That is why they are given the question, find the roots if they exist. Here the roots does not exist. Now we move on to the third method, that is solving a quadratic equation by quadratic formula. For a quadratic equation, ax square plus bx plus c equal to 0 where a not equal to 0, the roots of the equation is given by x equal negative b plus or minus square root of b square minus 4ac by 2a, provided b square minus 4ac is greater than or equal to 0. This is known as the quadratic formula. Here b square minus 4ac is called as the discriminant. So, a quadratic equation ax square plus bx plus c equal to 0 has two distinct real roots if b square minus 4ac is greater than 0, or we can say it will have two equal real roots if b square minus 4ac equal to 0, and the quadratic equation will have no real roots if b square minus 4ac is less than 0. Here let us see how to solve a quadratic equation with the help of quadratic formula. An example is given to you. 3x square minus 5x plus 2 is equal to 0. We can easily see that the coefficient of x square, that is a, is equal to 3. Coefficient of x is equal to b is negative 5 and the constant term is 2. Let us find the discriminant first. That means we need to find the value of b square minus 4ac. Substituting the values, we have negative 5 square minus 4 into 3 into 2, which is equal to 25 minus 24 is equal to 1. Square root of b square minus 4ac is equal to square root of 1, which is also 1. Now let us give our quadratic formula. X is equal to negative b plus or minus root of b square minus 4ac by 2a. b is equal to negative 5. Therefore, negative b will be 5. Substituting the values, we have 5 plus or minus 1 by 2 into 3, which is equal to 5 plus or minus 1 by 6. For finding the values, first we take plus. Therefore, x is equal to 5 plus 1 by 6, which is equal to 6 by 6, which is equal to 1. Or the second value, x equal to 5 minus 1 by 6, which is equal to 4 by 6, reducing, which becomes 2 by 3. Therefore, the roots are 1 and 2 by 3. Let us continue exercise 4.3. In the previous slides, we have done 4.3 using only the completing square method. Now, as we have learned the quadratic formula, let us continue the exercise. Find the roots of the quadratic equation using quadratic formula. 4x square plus 4 root 3x plus 3 is equal to 0. Let us find the values of a, b and c. That means coefficient of x square, coefficient of x and the constant term. We can see coefficient of x square, that is a, equal to 4. Coefficient of x, which is b, equal to 4 root 3. And the constant term c is equal to 3. The discriminant b square minus 4ac is equal to 4 root 3 whole square minus 4 into 4 into 3, which becomes 16 into 3 minus 48. Again it is 48 minus 48 equal to 0. Square root of b square minus 4ac is equal to root of 0, which is also 0. We have already seen if the b square minus 4ac is equal to 0, we have two real and equal roots. So x equal to negative b plus or minus root of b square minus 4ac by 2a is negative 4 root 3 plus or minus 0 by 2 into 4, which is negative 4 root 3 by 8. Cancelling 4 and 8, we can see our answer as negative root 3 by 2. As a quadratic equation is of degree 2 and we have two roots, we can see the roots are repeated. Therefore, the roots are negative root 3 by 2 and negative root 3 by 2. Let us move on to the next set of questions. Find the roots of the following equation. X minus 1 by x is equal to 3, where x not equal to 0. Here in this question, we can see it is not in the standard form. Always it will be better to write an equation in its standard form. To make the equation in the standard form, we are going to find the LCM. So the left hand side will be x square minus 1 by x equal to 3. Transposing x to the right side, x square minus 1 is equal to 3x. Now bring 3x to the left hand side. It will be x square minus 3x minus 1, which is equal to 0, and it is in the standard form. Finding the coefficients of x square, x and the constant term, we are going to find the discriminant b square minus 4ac. It is negative 3 whole square minus 4 into 1 into negative 1, which is equal to 9 plus 4 equal to 30. Square root of b square minus 4ac is equal to root 30. Applying quadratic formula, x equal to negative b plus or minus b square minus 4ac by 2a, we have 3 plus or minus root 13 by 2. So, the values of x are 3 plus root 13 by 2 and 3 minus root 13 by 2. Therefore, we can say the roots of the quadratic equation are 3 plus root 13 by 2 and 3 minus root 13 by 2. Question B. 1 by x plus 4 minus 1 by x minus 7 is equal to 11 by 30, where x naught is equal to negative 4, 7. Again, here also it is not in the standard form. Finding LCM, we have 1 into x minus 7 minus 1 into x plus 4 divided by x plus 4 into x minus 7 equal to 11 by 30. Opening the brackets in the numerator, it will be x minus 7 minus x minus 4 by multiplying the denominators, we have x square minus 7x plus 4x minus 28 equal to 11 by 30. Simplifying the numerator, we have x get cancelled and it will be negative 7 minus 4, which is equal to negative 11. In the same way, denominator we can see like terms negative 7x and positive 4x, which equal to negative 3x. So, we can write it as negative 11 by x square minus 3x minus 28 equal to 11 by 30. Cancelling 11 from left hand side and right side, we have negative 1 by x square minus 3x minus 28 equal to 1 by 30. By cross multiplication, we can see our equation will be negative 30 is equal to x square minus 3x minus 28. Rearranging the equation in the standard form will be x square minus 3x plus 2 equal to 0. Applying our quadratic formula, we can find out the values of x. They are x is equal to 1 and 2. Therefore, the roots are 1 and 2.